Right. Hello, everybody, and welcome. Hopefully, everyone can hear me all right. Um, First of all, welcome. My name is Matt Forrest over here at Wherobots, and I'm excited to kick off one of our first webinars in a series of webinars that we'll be doing, kind of going over some of the different components and functionality within our platform. So that's what we're up to today. First of all, thank you for attending and happy to have you here. Just a few of the kind of things and ways about. If you have any questions, don't hesitate to drop those in the questions section. There should be a spot to ask that in Q&A. As we go through, I'll get through those and I'll kind of walk you through some of the different pieces within that. So if you have questions, you can do that. Before we get started, you should have received a prompt to create a Wherobots account. So you will need to do that to get started. Just quickly walk through what you need to do that. So if you haven't done so yet, you can go to wherobots.com. To do that, you can just hit this big purple button at the top, try Wherobots. And then you can sign up one of two ways. You can sign up for a free community edition here. Or if you're already on Amazon Web Services, AWS, you can actually do that through the AWS Marketplace and click over there to do that. So that's another way to do that. You'll also get access to some free credits and a few other advantages if you go through the AWS route. So if you do that, it's a few different pieces there, but if you want to go through the community route, you can do that too. So either one will work just fine. So that will be, it's really up to you and what your preferences are. To get started, I'm just going to wait a few minutes to let a few folks in, but I just want to get a sense of where everyone is kind of tuning in from today. So if you're able to just throw that in the chat, let me know where you're joining from, and then we'll go ahead and get started in just let's do 2 or 3 minutes here. And I think if you did want to share where you're joining us from, you can put that in the should have access to the chat. So there you go. Haley, how's it going? South Shore of Massachusetts. Okay, I think I know where that is. 2 folks from the UK. Awesome. All the way from Nigeria. Welcome. Bay Area. Mexico City. Philly. Got a big playoff game coming up. Netherlands, Miami, Istanbul. And if you're curious, I'm tuning in from very, very cold Long Island, New York right now. So yeah, Miami, Mexico City, Istanbul all look quite nice from here. Afghanistan, welcome. Okay, so let's get started. I kind of have a very brief agenda that we'll go through very quickly. I'll just kind of walk through a little bit about Wherobots, what we do, kind of a little bit about the platform, how that differentiates us from different things. From there, we'll go through the account and signing up and getting started with the platform itself to walk you through where things are. And then we'll jump into an actual notebook to get you some of the very baseline functionality. This is kind of just scratching the surface of what you can do. So there'll be a lot more that you can actually do with that. But yeah, that'll get you just started, at least from the beginning. So let's go ahead and get started here with the presentation. So really why we exist, or why Wherobots is around, is that the first thing is that there's challenges between geospatial, ETL, data pipelines, and then getting to the final phase, which is the analytics, even working with machine learning or AI. I kind of call this middle phase that's been very difficult over the years. We have a lot of geospatial data, and I think most people here know that, is that there's a plethora of imagery. There's a lot of different data sets being produced, either internally or externally, and the data is getting larger. It's not so that every data set is unmanageable, but there's certainly lots of data that's there you're able to work with. On the other end of the spectrum, with the final product, we have a lot of great tools to visualize data, showcase different things, create compelling maps and analytics and all these different things on the end. In that middle part, getting from raw data or data that's being produced through to something that's ready to be used in an analytical setting to ask questions of can be somewhat complex, especially when this data over here is changing all the time. It might be getting updated. There's new data coming in. There's different things happening. That part can be quite difficult. So there's this middle ground of kind of difficulty that has always been there. And we've kind of created a mix of tools that kind of work. But I kind of call it like we're kind of duct taping things together, right? It's very, just kind of things that are patched together. So one problem with that is that won't scale. Like if you are just doing workloads in GeoPandas, you're going to have to try to scale that pipeline. It's going to be difficult, but you're going to have to throw resources out there. It's not scalable out and things like that. Cloud data warehouses have kind of started to fill that gap, but they're really meant for read intensive workflows. I just put a post about this on LinkedIn today. They're great for reading large amounts of data, but processing data can get really expensive and cumbersome, and not all of them are ready for geospatial data. Things like PostGIS are amazing database tools, and they have a lot of different functionality in terms of spatial functions within them, but it's a database that data has to live in memory, and it's hard to scale that out, and it can become quite large and costly, especially if you're working in a cloud environment. So because of that, there's these problems with things that won't scale. The other piece is that so the preferred architecture for that is what's known as like a cloud data lake, right? Or a data lake house, a lot of different terms for that. But basically, the whole concept is that you have your data in a cloud storage environment like Amazon S3. You could have it in Google Cloud Storage, Azure Blob Storage, whatever. You're keeping your data there, and then you bring computing power to that and distribute that computing power across it. So as your workloads get larger, you can add more computing power and scale that. Data warehouses do this to a certain degree, but even tools like Spark or Databricks or Microsoft Fabric, this is effectively how they're built. They have storage that's separate from the compute layer. You bring the compute down to that and you scale it out as you need to. The problem is that they don't natively really focus on geospatial workloads. These are built for log data, basically things that are being generated from computers, all this different stuff. So there's a lot of different things that it does really well. Geospatial today isn't one of them, unfortunately. So what does that mean? That's effectively how we kind of started to build out Wherobots. Now, Wherobots, if you're not familiar, is built upon Apache Sedona. Apache Sedona is an open source functional library that allows you to allows you to write the code to distribute spatial workloads on a variety of different systems. So connect to a variety of different data sources. And then you can run distributed computing workloads. When I'm saying distributed computing, that means using it in Apache Spark, some other systems like Apache Flink or even Snowflake, you can run Apache Sedona on. But it's most commonly used with Spark. I think that's how most people use it. It's a very large library. So some of you may have heard of it. If you have, that's great. And you can see here that there's lots of different organizations that are currently using it. There's 42 million downloads. So it's a very large functional library. What's great about it, and what we'll show today, is that you can work with workloads, both in vector and raster data, which is one key thing that a lot of these systems are missing, is that vector and raster data can sit side by side. So that's a little bit about Sedona. It's grown significantly over time, and even in the last few years, it's grown quite a bit. So this is before 2022. It was, previously called GeoSpark, then Apache Sedona. And then over the past few years, it's added a lot of different functionality to support more cloud native workflows with GeoParquet, very completely built out, vector and raster functionality, geography functions, things like that. So it's gotten to be a much larger functional library, which has added a lot of things to that. What Wherobots adds in are these pieces that you're seeing here. So obviously it uses Sedona as the functional library. The code we're going to be writing today is Apache Sedona code. So that's what you're learning. That's what we'll be going through, but it's running on Wherobots, which is where the speed, scale, and performance comes into it. If you're not familiar with distributed computing systems, distributed computing basically says, I have a workload problem, and I'm going to split it up across multiple compute instances, or imagine them as like multiple mini computers. If you're running code on your computer, it's running on a single threaded machine. It's one CPU, one computer. Distributed means it's running that on multiple. What we've done at Wherobots is create compute environments that are optimized for spatial predicates, spatial awareness, if you think of it that way. Basically, it works and it's built to work with spatial data. It knows things about spatial relationships and how spatial data interacts, raster and vector. It's embedded in those compute layers. That results in significant performance speed, which we'll show in a minute. So that's like kind of the main kind of big thing that we do is that our compute doesn't matter if you're running smaller workloads or the largest workloads possible, it'll be faster compared to other systems. There's also out-of-the-box raster and vector functionality. You can read in vector data sources from a variety of different data sets and locations, and we'll show you how to kind of connect that and work with data that you're storing or using. And we'll talk a little bit about raster data today as well. What's really nice about raster data, and this is something we won't cover today, but I will in a future event, is that you can actually connect to remote data sources. So and I'll kind of show you what that looks like, but imagine you have a raster data set like Sentinel-2 that's living on AWS. They have AWS Open Data. The data is living there. You don't actually have to transfer that data over. You can just connect to that remotely and reference that data. And when you query it, it'll just bring in only the pixels it needs, not even the whole data set, just the pixels it needs. So it's very efficient, no data movement. It's bringing your compute infrastructure to where that data is, no matter where that lives. So that's another big advantage. And then it's completely serverless and cloud native. We have functionality to, store your data in Apache Iceberg catalogs. Another topic we'll have a future session on, but that's, I think, one that's going to be very important coming up. And then even the raster functionality, we have machine learning or AI capabilities to either bring your own model, your raster inference model, things like classification, segmentation, detection, all those different pieces you can actually bring and run in a distributed setting in Wherobots, which no other system can do. Most of them are just running on a single GPU or CPU instance. We actually distribute that, and it runs much, much faster, especially for large workloads. So that's a little bit about what we do there. This is a little bit about what this looks like from an architecture perspective. You can connect in and bring your different data sets from AWS S3 or different places like Databricks or Snowflake data stores, open data sets. And then, it runs on, you can connect to Apache Iceberg or store your data in Parquet format. That's through the Wherobots DB. Now, Havasu is like a Apache Iceberg. It's a catalog system. It kind of treats your data like a database, but it's just a file system. Like I said, we don't have time to get too much into that today, but that's something that is unique to Wherobots is that we're the only ones that can create Apache Iceberg with geospatial data today. We're working on merging it back into the project, so that should be out soon. There's Wherobots AI, and then here's kind of what we'll be looking at today, which is this is the spatial notebooks functional layer where you can write code in SQL and Python. So this is kind of where we'll be focusing in on today to get you started. Now, kind of how the performance scales up. This is a little bit about that. This is, not from us, from someone else, but this is actually, I think, posted like yesterday on LinkedIn to just show you how the speed and performance scales up. And if you see here, just from this switch to Wherobots, the spatial joins and geospatial workflows were about 80% faster than BigQuery for this team. So I think this is the CTO of Dauntless. So just to give you a sense of like scale and speed, this is kind of one of those big changes that we have there. So with that, if you have any questions about Wherobots, feel free to drop those into the Q&A. I'll be checking those periodically. Let me see if there's any yet. So no open questions yet, but feel free to drop those and I'll get to those as we pop in. The first thing we want to do is get our accounts open. So this is where we'll actually go along and work on this together. So if you have not signed up for your account yet, please do so. Go to Try Wherobots here. Go through the sign up process. You'll get an email to kind of, there'll be like a confirmation code to confirm your email. And once you get all the way through that, you should be able to log in here. And this is what you'll see when you open up your Wherobots Cloud account. So I'll just, if is anyone having any trouble getting signed up or is everyone signed up? If you just want to throw in the chat, yes, I'm logged in, so I know people are following along, that would be a big help to me. Okay. Okay, great. All right. So it looks like people are logged in. And now we can kind of get a overview of Wherobots from the cloud service. So when you log in, this is where you'll land. This is the notebooks interface. There's a few other, some information here if you want to get into help and guides, some documentation here as well. But this is where you'll you'll generally start, is that you'll be creating a notebook instance. And then you'll have access to different compute environments. If you signed up for the community instance, you'll have access to the tiny compute environment, which is here. But if you have it through AWS Marketplace, you should have access to some more of these as well. So to create a compute environment, all you have to do is you can give it a name if you want, or just hit start, and that will start that. So you can go ahead and do that. In the case that you want to install additional Python packages, all you have to do is kind of create a new compute environment and add a dependency. So if you wanted to, say, install something very specific, let's say like Gmap or Felt Python, you can do that. You do have to designate the version number, just using the equals version, and then you can create your own preset, and then you can save those. I have a bunch of them saved here, which I've used in the past for different things. So you can do that, but you don't need anything special to run what we're doing today. So go ahead and hit start. That will start a compute instance for you. That's the smallest one available, but still has quite a lot of power in it. So you can go ahead and get started there. As you're starting that, I'll walk through a few other pieces here just to give you a sense of what we're doing. This is the storage section. So if you have data in cloud storage, you can actually create a storage integration to your data if that lives in Amazon S3. So you can do that here if you want to connect to data that you already have. If you don't, we also give you access to your own S3 buckets. So if you click into data, and then you'll see it's customer dash alphanumeric code. This is my unique customer data set. From here, I can start uploading data to S3. Now, Wherobots works with data that lives in S3. You can connect to like public S3 sources. There's a few other configurations you have to do, but we have data that is already pre-programmed into notebooks, so there's no extra steps to do today. But if you did want to upload your data, you can add some more files here and read those files in. So that's something you can do as well. Create folders, stuff like that. So there's options here. Now the spatial catalog is connecting to data that we provide. There's some open data sets here. There's like the Foursquare Places, Overture Maps data sets, and a few others. You can also create your own catalog. This is the Apache Iceberg catalog piece. So if you look at it, here's mine, and here's like I loaded a bunch of data from the New York City bikes. So it looks like a table, right? In a normal like a SQL database or a data warehouse or something like that. So it'll look just like that, but this is basically where that metadata is stored. This is the catalog reference. So that JSON file is storing that catalog reference, and I can actually query this just like a table. On the back end, it's actually just a bunch of Parquet files and a JSON file, but it's treated like a table, and I can do inserts and updates and all these different things. This is where this is basically what a lake house is, right? You're not just storing your data as tables or files, you're storing your tables, you're storing your data as files, but it gets represented as a table. There we go. And that's kind of what that is. So we provide that functionality to you, not only to read from an Iceberg instance, but also create your own. And I think we're the only solution that allows you to create spatial Iceberg out today, allows you to do that. So once you've been through that, if you've been through and started the notebook, you should see your notebook instance here that's active. You can just go ahead and click open, and that will launch a new notebook instance for you. So if you click open here, I can go ahead and close that out. And this is what you'll see. So you'll probably see something a little bit different than mine. I have some folders here that I've stored other things in. If you do want to create and store something of your own, I would recommend creating a folder here in this top level view, because that will keep your data, your notebooks alive from that point. If you shut down the compute instance, it won't save those. But if you create it here, as you can see, I just created a folder called Matt, and that stores a bunch of my other stuff. But you don't need to do anything to get started today. The first step you want to do is just open up notebook examples. click into Python. Oops, sorry. Sorry, examples at the high level, Python, and then onboarding, not notebook examples. So once again, examples, double click into Python, and double click into onboarding, and there should be one notebook available to you there. So this is our notebook that we'll be going through today. I'm just going to turn off the file system here. And this will allow us to do a few different things. So if, once again, if you just want to let me know if you're on this notebook, you found it and you're able to see it, just let me know in the chat. I'll keep an eye on that and I'll kind of walk through what we're going to do. Okay, looking good so far. So what we're going to do is kind of walk through this notebook to show you these very basic first steps in Apache Sedona and Wherobots. So we'll show you how to load raster and vector files into data frames, right? You're going to create a Sedona data frame from your data with data that's loaded in S3. We'll do some very basic stuff like doing zonal statistics with our data. We'll transform and analyze our data. We'll show you how to create a temporary view, which basically turns your data frame into an object that can be queried in SQL or in Python, doesn't matter, but we'll show you both. And then we'll show you how to visualize some data. Oops, I didn't mean to do that. Using Sedona Kepler, which is a Kepler GL integration into Sedona notebooks. So now before you get started, like I said, you can use our fully managed storage, our S3 storage that I just showed you earlier, and you can load data into there. If you do have your own S3 bucket, there's some more information on how you can do that here. Just click that link and that will show you how to get that all connected. So if you do have your S3 data, you can basically turn your data into a spatial data lake from there. And then you can go from there. So that if you do want to do that, you're more than welcome to. Okay, so the first step is to basically connect this notebook to that compute instance that we already started. And to do that, it's 3 simple lines of code. From Sedona, we're importing the Sedona context. And you can see here, I'm just going to make this a little bit bigger so we can all see as we go along. I'm going to create a configuration, which I'm going to basically call the Sedona context to build that, and then get or create. If one exists, it'll get it. If we don't have one, it will create it for us. And then to create my Sedona reference, I'll do that. I'll create it from the configuration. So that's it. That's all you're doing here. And this will connect us from our notebook to our compute environment. And that's all we're doing here. So you can go ahead and run that cell. You can hit Shift and Enter, Shift Return, or you can just hit this play button here and that will run that cell for you. And that will then connect us to that compute instance. So this step may take a few moments to get started if you do have to create this, which if you haven't run this notebook before or done anything in your compute environment, then it will take a minute or two to do that. So we'll wait for that to load, and then I will just walk through the rest of the steps here that we're going to go through. So once it's done, you should see a number, probably number 1. If you haven't run this before, but it should, instead of showing an asterisk, it should show a number there. That will tell you it's been successful. So our first step is we're going to read some GeoParquet data into a data frame. So GeoParquet is one format that we read. The great part about Sedona is that it allows you to read spatial files without any sort of transformation, turning it from one format to another, anything like that. It just kind of reads it. So GeoParquet is one format. We read things like GeoJSON, GeoPackage, shapefiles, and then many different raster types like TIFF, NetCDF, stuff like that. So that's the first big advantage of Sedona is you don't have to like change all your file formats around. If there is a format that we don't read, you may have to translate that or turn it into some other format. But for the most part, we cover the big and most commonly used formats that are out there. So we'll start with GeoParquet because it's an efficient file format. There's a lot of reasons why GeoParquet is really good, but this basically shows you how to do that. So if you're familiar with a GeoPandas workflow, it's will kind of feel similar, but basically we're saying to first load our data frame from calling Hey Sedona. So we'll tell it to read the format and we'll define the format as GeoParquet and then load that from a S3 URI. And then we can actually see our data using a few of these commands. You can print schema to show the schema. Show will show the first 20 rows of a data frame. And then if you pass in a number, we'll give you the first 5 rows. So just confirm you can run this step after you've seen that this context has been built. So you can actually see that that loads in there. And then we'll go ahead and load this in. So if you just hit Shift Enter, this is a public data set of buildings in New York City that I've loaded up. And you can see here that buildings has loaded in using that format, Sedona read format GeoParquet. And then we loaded that S3 URI. So if we wanted to actually see the data frame, buildings now holds that data for us. You can say print schema. And then that will just print out the schema for us. You can see here is the build ID. And then most importantly, we have our geometry attribute here, which is our geometry. So we have a bunch of different data here, like the city, address, state, zip, stuff like that. This is data from FEMA, the Federal Emergency Response Agency here in the US. So if I wanted to see the first 10 rows, I can, or sorry, the first 20 rows, I can go show. If I wanted the first 5 rows, I can just pass 5 in as an argument there. And then that will return the first 5 rows of that data, which you can see here printed out nicely. Okay, has everyone gotten through that step, that first step reading in GeoParquet? We do have a question about projections. For GeoParquet, it stores, I believe you can store projection attributes on the metadata with that, yes. So. Okay, so moving on to the next step, as you can see here, I have a new data set here that's actually pulling in a raster file. So this is a GeoTIFF file that it's data from the New York City Open Data Set. It's I believe it's a 1 foot resolution DEM or digital elevation model for New York City. But this specific one I just clipped to only look at Central Park because it's a pretty large file, as you can imagine. So just for speed and efficiency, since that's all the data we're using today, I'm just going to use that one. So in this case, instead of using Python, we'll just to demonstrate that you can read this in through SQL, we're going to pass a SQL statement here, select RS from path, pass in our raster path, which is this S3 as the raster, and then you can kind of show the schema here. If you did want to load it through Python, you could do it the same way here, read the format, binary file, the raster path, and then just use that function to express that, through Python here. But for now, we can just show this as a raster data frame. So I'll hit enter here. That's all we have to do. And then basically the nice part about Sedona is that it's just kind of storing the reference here. It's not actually running anything yet. So if I actually wanted to see this, oops, it will now actually run something and do that. So it's not actually going to do that. But you can see it references out to the raster. It's now referenced to that raster data set. And we can now do raster things with that raster data set that we've referenced in. All right. Has everyone just give me a thumbs up or let me know if you're up to this step here. Just want to make sure I'm not moving too fast and that everyone's able to follow along. Okay, great. All right, thank you. Okay, so the next step is that this is kind of a something in Spark that we need to be aware of, is that we need to turn that data frame into a view. Now, a view is kind of a very database-like term. A view basically means that we're creating a snapshot of that data that can be referenced and then queried. So that's basically what we're going to do. It's pretty simple. You just call that data frame and say create or replace temporary view. We don't need it as a stored view or anything like that. We're just doing a temporary view. And now that allows us to do that it allows us to use that as a table reference in spatial queries. So we'll show what that looks like. So that's really what's happening here. You can do some different stuff like select star from elevation or whatever you want to do. But that's basically what we can do here. So it won't, once again, it won't do anything yet. It's just storing that as reference. Once I actually query something, which is in our next step we'll do, then we'll actually do that. So what we want to do now is basically find out what's the elevation of the point location of Strawberry Fields. If you're not familiar with Central Park, there's like maybe you've seen a picture of it. It's like a memorial to John Lennon, and it says Imagine, and it's kind of like a tiled mosaic. That's known as Strawberry Fields in Central Park. So what we're going to do is pick that location, And using standard spatial SQL, we'll call st_point, which will create a point reference at that location. Point geometry at the location. And then using rs_value, which is a SQL function from Apache Sedona, we'll extract the value of that raster file from that at that point. So that's really what the SQL query is doing. And we'll just return it as the elevation in feet. Sorry, I have a little bit of cold, so if my voice is a little off, that's why. And then basically return that as that value in feet, since the spatial projection uses feet as the reference. Since it's New York, they use everything in feet and miles, not meters. So that's what we're doing. And as you can see here, it's using from elevation. This data frame that we just created is now, since we've created as a temporary view, we can now reference it just as a table. So if you run that cell, nothing again will run. It's just saying, okay, I know what I need to do with this query. I can print and see the query plan and stuff like that here if I wanted to. But to actually query that, we're just going to hit .show. And you can see here now it's running a stage, which means it's basically running the query for us. And you can see here that it is 90 feet. The elevation at that location is 90 feet. So I checked it against like some find your elevation online thing, and it was actually right. So if you want to check it yourself, you can go ahead and do that. But that's basically it, is that you can run and query this with raster, kind of functions. This is one function out of many. If you're curious and want to go deeper here, you can go to docs.wherobots.com. And in the reference here, you can see all of the different raster functions that we have. So there's lots of different ways to work with raster data and raster functions. So you can see all the different types here. Same with geometry data. There's just about as many functions here to work with geometry data. So you can check that out if you want to get deeper into the functions, just kind of the showing you how to get your data in and querying it and working with it today. So that's our first job. So yep, we did our piece here. Now, oftentimes you're going to want to actually see your data. We have an extension that allows us to do that with, Kepler GL, which is a common visualization platform that's built into Apache Sedona. It's called Sedona Kepler. And basically, we're going to create a map that visualizes those that building data set we have. Now, I pre-prepared a map configuration file that's already loaded into this. So it's already set up so you can actually just read the map config and it will show in the same style. If you did it just, without the configuration, you could restyle this yourself, but it kind of shows you just as a quick step to visualize what you can do within the context of a notebook. So to open that up, I'm going to open up the map configuration and load that in. And then I'm going to import from Sedona Maps and Kepler the function to create that. So as you can see here in this line, I'm going to create my map using my map configuration. And then I'm going to add my data frame to my map. So I'm going to add it to the map. It's going to be the buildings data frame. And I'm going to call that layer NYC buildings. And then I'm just going to return the map. So if I run this cell here, it will create my map for me. And then in a moment, I should see a nice map that pops up here. All right. So if you can see the map, if you got this step, once again, just give me a thumbs up so I make sure we're moving at an okay pace for everybody. And what you can see here is basically all of those building footprints that I loaded in New York City. So just to give you a sense of how I'm styling this map, you can see here I'm styling it and I'm going to base it off of a specific column. That's the primary occupancy code or the primary use of the building type. So if you see here as we zoom in, you can see these are all residential, or it's classify these as retail trade. It's very interesting. You can see here there's residential, multifamily dwelling, things like that. And as we move into Midtown, you can see light industrial, which is how they classify office buildings at FEMA. It's a kind of a funky data set because it's derived from satellite imagery. So you can see here that this whole block is classified as a single building, which is strange, but since it's from satellite imagery, that kind of makes sense. But you can see here there's also ones that are hotels or temporary lodging. You can see here some of the pink buildings are residential as well. I think there's some different ones, government services, utilities, but you can kind of see how quickly it could load up all these different buildings and visualize them. And there's obviously a height attached to all of these. So you can actually see the different buildings here as well. But these are the actual building footprints that FEMA uses to do emergency response management. So I think it's an interesting data set to look at. But yeah, you can kind of see the map here, and you can see how the colors change as you move throughout the city. There's different things happening in different areas, but some of these are retail, commercial, but in New York, there's usually like a retail on the bottom level, residential on top. So maybe that's how they're classifying those. And then obviously up here, universities, I think this is Columbia up here and some different colleges. So, okay, cool. So moving on, we're going to do one last thing today before we wrap up and kind of show a zonal statistics function. But what really kind of surprised me when I was, kind of working with Sedona for the first time was how effortless it was to move between raster and vector data. Now, for me, I kind of come from the cloud database world, and either if you're not using PostGIS, because PostGIS can read raster data, you have to transfer and vectorize your raster data, which can be a very computationally heavy process. If you're coming from a Python world and you could be mixing GeoPandas with Rasterio and do some different things there to make it work, it certainly can work, but it's not, I would say, enormously scalable, right? What's nice is that I have two data frame objects, a raster and a vector, that sit side by side. And for me, coming from the database world, I can write simple SQL to do that here. Or if I'm coming from Python world, I can express this through Python as well. But there's no data transfer. I don't have to vectorize my data. I don't have to do anything extra to make it work. It just kind of works. So what we're doing here is basically we're going to find the elevation of all the buildings that fall within Central Park. So if you see here, there's a bunch of kind of small buildings that are in Central Park, and then one giant building, which is the Metropolitan Museum of Art. So and a bunch of other smaller buildings down here, kind of variety of different things. I don't know what all of them are, but yeah, there's buildings in Central Park. So to do that, we'll be writing this statement here and writing this SQL statement. So you can see to call a SQL statement, I just have to write sedona.sql, and I can kind of fill that in and go from there. So the code that we'll be writing will basically have our two inputs, our elevation. Oops, sorry, keep double clicking that. Our elevation table, which is the 1 foot digit DEM in our buildings. So we have the data set of all our buildings. First things first is that we need to transform our buildings to the correct projection. So all New York City data uses this 2263 projection, which is it's a New York State planar projection. So it uses feet. So we'll turn our buildings from 4326, which is the projection that is just, for, your regular geographic coordinates, into 2263. So we can read that. And we'll do that twice here. So we can kind of do that on the fly. And then what we'll be doing is using this function rs zonal stats. So let's take a look at what that function does. If you open up the docs, we can type that here, and that allows us to basically get for all the pixels that intersect a geometry, we can do things. We can count them. We can get the sum. We can get the average, median mode, standard deviation, variance, min-max. So it can return all of those. It will run on band 1 unless we specify that it runs on another band, but this is a one-band, raster data set, so it's only one band. So we will specify it just so it shows you that in the code. And then there's one final argument here, which is, let me see here, the final argument, which is, why can't I find it? Oh, sorry, lenient. So this will, if it's true, if there's no intersection, it will kind of give it a leniency in terms of the intersection, but you can control that if you want. So that's what we'll do here with the rs zonal stats. So you have the input raster. The table basically stores everything in this column called rast. So you can call it raster. I call it rast for shorthand, but it stores all the data, the values, everything in there. We'll have our vector geometry, the band. And sorry, this is ignore no data. Sorry, I don't know why I said that. It will ignore if there's any missing data in the raster itself. We also want to provide it a spatial predicate. So if you see here, rs intersects, it's basically like an ST intersection. We only want to look at buildings that intersect that raster data set. Why we want to do that is, if you remember all the way back to the beginning, those compute nodes are optimized to look at spatial data. So if we tell them, hey, only look at the things that overlap from the raster and the vector data set, it can ignore everything else. So it's smart enough to do that. Other systems aren't smart enough to do that, basically. So that's what we built into that. And then we're just doing a group by the building's address and the building's geometry. And then we're only going to select here to find anything where the elevation is above 0. Because I clipped the raster, there's a few 0 values in there. It didn't store as no data, unfortunately. So we're just ignoring everything where elevation is 0. Zeros are no data value in this case, unfortunately. So that's what we did. So that's what we'll do here. So if you move down to the code here, the first thing is we need to create that temporary view from the buildings data set. So we'll do that here. And then we also want to see and just confirm that SRID. So you can see here I have this function rs underscore SRID to find the spatial reference ID for our raster data set, which we already know is 2263, but you can see it here. And then we're going to run our query here. So this is that full query that we just went through that I explained. If you see I just save the cell, it's not going to do anything. It's just going to create a reference to this query. I can actually, if I want to see the query plan and things against that, it'll run, but only when I run a command like .show. You can also run a command .count or things like that. You want to see those different things, but since we want to actually run that, you can go ahead and quick hit .show, and it'll actually start to run that. You can see as it's going through here, it's executing the different phases of the process here. Now, if you do at any point need to see where this is, if there's a debugging or error, it will actually stop at that specific step and cancel out or error out, which is nice because if you're running this, say, in PostGIS or something else, it may actually try to complete the whole thing and then you don't actually know where it broke down. So you can actually kind of work to debug that a little bit more efficiently and go from there. So once that loads in, we should get, this is probably the longest command we'll run today, but it'll actually get us all those different values back. So we'll let this go ahead. Is everyone up to this step so far? Just give me a thumbs up and let me know that. That'd be great. Cool. So once that completes, then we will take a look and see our results on a map, and that'll kind of wrap up our tutorial for today. So and then I just wanted to pause to see if there's any questions, if you want to throw those into the Q&A. I see one here from Lee. So right now we work primarily with AWS, but we're looking at other providers. Azure is definitely one that's on our list. So we're actively kind of evaluating and seeing what we need to do there to get each of those out. So, but Azure is definitely on the list. Cool. Any other questions? GCP, yeah, basically we're looking at Azure and GCP as the two main ones we want to evaluate. So that's the most commonly requested ones that we're looking at. So yes, those are both on the list as in terms of evaluating. So feel free to keep dropping any questions in. But as you can see here, we now have our elevation, our data set has returned. So you can see here, I have basically my 3 columns that I've defined. We have the elevation here, the building name, which is basically the address of the building, and then the geometry. So now we can actually plot that data here on a map using Cinema Kepler again. I provided a map configuration again, so you don't have to style anything, at least in this case. And then we'll plot that on a map and see what that looks like. But if there's any more questions, just feel free to drop those in and we'll keep answering those as we go along. And then as you go forward from this, like I said, we'll keep a regular series of these going into some deeper pieces of the platform. If you do want to get started and try some things on your own, I recommend heading over to the Get Started view here in our documentation. You can see here there's different pieces about how to get started, kind of, what Wherobots is, how to use Wherobots DB, some different pieces there. There's also this section, develop and deploy, to actually use some different things. So you can see here how to use the spatial catalog, to use, different, notebooks and data storage, pieces like that. If you're creating some different jobs, you can actually run those via Airflow. And there's actually like a runs kind of API, or sorry, runs endpoint that you can use there. And then this is probably the most like functional section if you're doing data processing and analytics, which is obviously what's called. But you can, look at how to load data from different storage. Here's different data types from JDBC, GeoParquet, shapefiles, Shapely, GeoPandas, PostGIS, whatever you need there. Here's how to save those results in these different pieces here. So you can check all of that as well. Here's another section on doing that with raster data. You can create map tiles via PM tiles as well. And then if you have either upgraded your account or signed up via AWS, you'll be able to run some of these geostats functions. So you can do things like, do some spatial clustering, and then obviously the raster inference. There's example notebooks to do this in raster inference as well, should you want to do those different pieces too. So this will give you a very functional view if you want to go through this on these different things. And then here are our buildings. So just we can kind of see it here that each of these buildings now has an elevation tied to it. So you can see here that this is 45 feet above, and this one should be a little bit higher, 95 feet, 81 feet, and then, yeah, 92 feet as you move through the park. So these different elevations here throughout Central Park. It does change elevation a lot there. So a few other questions. Can apps be deployed from Wherobots, or do they deploy in containers? In terms of like applications, the notebook service here, or the compute service, deploys basically as a compute service. Now you can spin those up via the notebook server here. There's also basically an API call to spin those up programmatically. So you can spin those up, but basically it deploys kind of like as a contained service. If that's not like, it's not a container that you control, it's like a managed container that we work on, but we do that there. The recording will be, yes, we're recording this so then we can share this after the fact too. So yes, and there's a video on YouTube that goes through this tutorial as well if you want to watch that as well. Just check out Wherobots on YouTube and you can see that there. And then, yeah, so the spatial, so the notebook runtimes, if we go back to our cloud here, you can see that there's these different runtimes here, and they have a different spatial unit tied to them. Spatial unit is basically how we price. So each notebook service comes with a spatial unit per hour. And then that's how we basically price that out. So if we go to wherobots.com and then just click out of the chatbot here. There should be a section on pricing here. So there's a pay-as-you-go model that basically says, it's $1.50 per spatial unit. And that's what it would cost per hour. So depending on the service you spin up, it's $1.50 to run that container for that specific amount of time. And that's basically how the pricing works, pay as you go, or if there's a contract-based option if you want to, buy in bulk, basically. That's kind of what we would do there. So we can kind of discuss those different pieces there. Which is the better option, signing in through AWS? I would go with AWS because then it runs directly through your AWS billing. So you have billing in kind of like one place. So I'd sign up there, and then you actually get $400 in credits for the first 30 days if you sign up through AWS. So thank you, AWS, for doing that for us. So you can actually sign up there. So that's the preferred method, I guess you could say. Either one works, but that's usually going to be a little bit easier. Plus you get the bonus there. Cool. Any more questions for today? So if you do have any other questions, feel free to just reach out to us. You can go to our website. You saw the little chat bot there. You can reach out there and post a question, and we'll take a look at those. If you want to reach out to me on LinkedIn, feel free to do so as well. And then if you want to get started, like I said, I would recommend taking a look at our documentation. This data processing and analytics section is really good here to give you a full view of some of the different things you can do. And if you have any questions, we'd be happy to, want to go deeper on specific topics. Just reach out to us. We can set up a short session with our team to kind of dive in and go through some of the details if you have some specific questions or problem areas you want to focus in on. But for today, I hope that was really helpful, getting you a very, very short introduction to what we do at Wherobots, how our platform works. And then, actually doing some very basic stuff with the Wherobots platform. Like I said, we'll be having more of these come up as we start to build these resources out. But in the meantime, thank you for joining. I apologize for my raspy voice, just getting over a cold, but thanks for bearing with me. And yeah, enjoy the rest of your week, and hope to see you the next time we do this.